Hello and welcome back to Building Microservices with Go. With me, Nick Jackson. And it's always pleasant to see you. So what are we going to look at in this episode? Well, what I want to look at in this episode is kind of continuing along the lines of what we've been looking at previously. We've been working through our API. Now, where I kind of want to go now is start to look at file uploads. Actually, I kind of want to look at file downloads. I want to show you how we can use things like gzip compression with our services so that we can compress our files and make them just really, really quick response from the server. We can do all of this with the Go standard package, which, you know, is always pretty amazing. So that's where we're going to go. I was thinking if we have time, we'll look at both multi-part and the ability just to kind of upload binary. I think what I'll actually do is concentrate on just kind of simple file uploads in this episode. And then I think we'll do a separate episode on multi-part files. It's a little bit more complicated. But should we dig in? Why not? Let's go. So what I'm trying to teach you with this course is going through the entire process. I want to kind of introduce the concept slowly to kind of get you used to using Go as a programming language for building out microservices, but kind of teaching you the concepts. There's a lot of great stuff in the standard library, which I think is really, really suitable. And I think it's worth spending time to consider that rather than just kind of diving in and just choosing packages. There's some kind of questions around, will I look at things like SQLX? Yeah, I actually really like SQLX, which is a kind of a package. I wouldn't say it's full-on object relational modeler, so full-on ORM tool like GORM or something like that. But I think it's a really nice blend of using kind of just the base SQL packages, but having the ability to annotate struts. And we'll see all of that and in an up-and-coming episode. But for now, it's always wonderful that you're here and you're joining us. And let's look at our old friend package HTTP. So what we want to look at today is a way of uploading files. And actually uploading files in Go is pretty straightforward. And the reason that it's pretty straightforward is because we have, as part of any handler, this HTTP request. And inside of the HTTP request, what we have is a stream, the request body. And let me just find that in the docs for you. So body is a stream, and the nice thing about the fact that body is a reader is that it can be used. It's very generic. Obviously, read closer is an interface. It's a combination of the IO closer and IO reader. But the benefit is that it's very versatile having this thing. From a kind of a technical standpoint, it's also very efficient because when you send a request to a Go service, Go isn't immediately kind of buffering all of the data that's sent to it. It gives you the capability of doing it gradually. You can read the data as it's kind of sent up to the wire, which means that we can do a lot of nice things like making sure that we don't accept too much data. You don't want to stream 10 gig of data when actually your maximum file upload is 3 megabytes. And using the reader and being able to control the number of bytes are read, very, very nice way of doing it. It's all very standard. You know, the kind of the same tool that you will use when you're trying to read and process JSON is actually the same thing that you can use for files. So let's see how that works. Let's kind of dig into that simple example. So we have our old service. So what I've actually done is I've started to scaffold out a new service, and I've called this one product images. It's in exactly the same code repo. You'll find it just where the other stuff is. And the reason that I decided to kind of go and take a new service is that I kind of want to be able to teach you microservices and the kind of to start to show you how we can actually connect these. So by being able to kind of build up our estate from a number of maybe smaller, simpler services, I think in the long run you'll see is very, very beneficial. But for now, we're back into our main.go, and we're using exactly the same pattern that we used in the product API. The responsibility of this service is that it's just going to allow us to upload images. So a couple of kind of just simple things. We are going to have some configuration. We're going to be able to configure the bind address, the log level. So do we want debug logs or stuff? And we're kind of just building on that pattern from earlier. And we're defining through environment variables the source of our images. Hands up in the air. In reality, this probably wouldn't make the perfect file service because we're actually storing files to the local disk. With an exception that I have thought about that. And the component that actually does all of the file writing and the file reading, well, it's an interface, so we could stub it out. So let's go. So the first thing that we want to do is we want to look at how we can send files to a service. And the type of files that we want to read are not anything complicated. It's literally just posting binary data with curl. So we do that in exactly the same way as we would do our kind of previous sort of stuff, where we're going to define a handler. So I'm going to call this my post handler. And again, I'm just going to do SM for my router. I'm going to do get http.method post, and I'm going to return a subrouter. So once I've got my subrouter, and if you haven't seen the kind of the previous videos where I've been running through the Gorilla Mux, then I'll put a link up here, and you can kind of go back and have a look at those. But it's nice and straightforward. So we're going to do handle func. So, and what is the path that we're going to use? Now, with the Gorilla framework, what we've got the ability to do is to specify the kind of the regex and other elements that are going to be in our queries, in our URI. So we're going to be able to follow that RESTful process of being able to kind of define controllers. So let's say we're going to call this, I don't know, images. Sounds sensible enough. And what I want to be able to do is I want to be able to upload images for a product ID. So it's going to relate to our previous service. So I can define my ID. And I can say that my ID is going to be a number, so 0 to 9, and more than one of those. So I can kind of use that regex there. Now, what I also want to do when I'm posting my file is I want to be able to specify the file name. Now, because I'm not using multi-part request, I can't get the file name out of the HTTP request. So what I'm going to do is I'm just going to use a parameter. So there's a kind of an argument, I suppose, around whether you would use multi-part or whether you would just kind of do the ability to handle files as an input stream. And I suppose it depends who your user is. If your user is a human or a web browser, then multi-part, like we'll look at in the next episode, is probably going to be the best approach. If you're dealing with things like pure API to API, then I think actually just posting straightforward body. Could the data be stored in a database? Yeah, I mean, absolutely it could. There's no reason at all you couldn't do something like that. You can store the data in a blob, in a data store. I think one of the kind of the more, I suppose, modern or traditional approach, modern and traditional, more modern approaches that folks use these days is that they kind of use cloud storage. So if you're hosted in AWS, GCP, or Azure, or on DigitalOcean, all of those clouds have the ability to give you access to cloud storage, which is very, very inefficient, very, very inexpensive, and very, very simple to use. You basically just have an API. And that satisfies the dependency of a microservice where state can be an issue for you. as I say, the approach I'm taking today, I'm storing it on a file, but I've already thought about the abstraction ahead of time. You could rewrite the interface that I'm using for file storage to S3 or wherever you like. Very, 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 very easy. So we're going to post a file name, and I want to call that parameter file name. But what I can do is I can actually, using Gorilla, one of the nice things about Gorilla is that I can define a regular expression for gosh, I did not want to do that. A regular expression for my parameter. So I can say that file name must satisfy this regular expression, which is made up of letters, A to Z, lowercase and uppercase, more than one letter, and then it must have a dot, and then it must have a 3-character extension between A and Z. Not the most perfect file name, I will give you, but it's absolutely fine for this simple example. You can kind of change that out to whatever you want. And then what we want to do is we're going to pass it our handler func. So I've kind of set up the sort of the basics, and we can have a look at that and start implementing our handler now. So we have a file handler, and our file handler has some parameters. It takes a file store. So previous episodes I've talked to you about dependency injection and how useful that is. I really like using dependency injection on my handlers because I'm passing in this files. Well, files in this case is a strut, but it could be an interface. That means it's replaceable. So I could replace files, which anything satisfies the same interface, and it gives me the ability to test ability. So when we look at testing, you'll see how this pattern I use very effectively, I think, to be able to write unit tests for the logic inside of our handlers. So we've already got our kind of our serve HTTP set up there, and we've got a logger, and then we're not doing much, but like, what are we going to do? Well, we don't need to sort of validate that the file name and the file path, but we can kind of just then save out this file. Because we've defined that regex in main.go, here, we don't need to validate again that file name as a parameter is going to match this regular expression. If file name from muxvars is not null, it will satisfy the regular expression. So the same as the ID. So I can write a very simple check here. I can just say if ID is not equal to blank string, and well, I can actually say if ID equals blank string, if I can press the equals key, or file name equals blank string, then we want to return an error. So I'm going to do http.error, and I'm going to do RW, and I'm just going to do, oh, well, look at this. I can just call this function here, invalid URI. Nice and easy. F.invalid URI. And that's just writing out the log. So we'll see that in action. Let's give this a little bit of a test. So r.uri dot string. And that takes the response writer. Okay, then we'll return. All right, so let's give that a test. Let's take that that incremental approach and give our application a quick test. So this you can find this service in the product images folder. Okay, so we've got our service, always the keyboard, never anything else. So I've got my file service now. So I can technically kind of upload a file, and I've got test.png there. So let me show you how I'm going to do that. I'm just going to use curl. So I can just do curl, and I'm going to do localhost 9090, which is where my app is running at. And I need to give it a path. So I'm going to give it a path of 1 and an invalid file name. And it doesn't really matter, but let me just specify my file, test.png. So I get product not found because we said we were going to put this at root this as at images. And it's not going to find it. And the reason it's not going to find it is because I'm using an invalid syntax. So if I kind of go through that, and this is kind of one of the benefits of using something like, oh gosh, GoRouter, that it gives me the ability to kind of do all of this really nice stuff. You can see there I'm now validating my files, but I'm getting an error because I don't have that image corrected. So we're good. So far, so good. So let's take a look at what's going on. So I'm uploading my file, and my file upload handler is very straightforward. There's not very many lines of code here. And I'm going to this function here, and I'm calling save file. Well, what does save file do? It's a really kind of straightforward and simple implementation. All save file does is there's a file path.join, and then it calls my file store component. So I'm just building up my path. I'm taking the ID and the original kind of file name, and I'm just building that up into a physical file location path. And then in file port path in my file store, there's this is a pretty straightforward component. And if my Go language server was actually working, we'd be able to see that. And there we go. So we have this interface. It's a storage interface. It has save, path file, and then if we look at the implementation, all we're doing is writing a file to disk. So it's nothing particularly clever there. It's just using the standard I/O to write a file. And I think that's kind of nice. So again, because I'm doing this injection, I've got this substitution, I'm basing things on an interface, I'm using local here, I could use cloud storage, I could use whatever I want. So let's take that and give that a little bit of a whirl. So, and finally, okay, sorry about that. So if we look in file store, we can see that we've created the folder 1 and we've uploaded that file there. So the file we've uploaded, which was actually test.png, we've just kind of given it a random path. So if let me just open up a new terminal rather than kind of going to that one, and I'll just do that curl again. But whatever I kind of choose the file to be as here, it's going to save that into this folder here. And it's just doing that because of the way that I've got that set up. So that's in its absolute simplest how easy it is to upload a file. Now, if I wanted to do something like restrict the size of the file, again, if I'm using like a multi-part stream, then I'll show you next time how that is automatic. But all of these things, the kind of when I'm saving that, I'm passing the responser, the read closer. And in my file save, all I'm doing is using os.file create and with the file path, and then I'm using copy. If I wanted to restrict the number of bytes, instead of using copy, I'd be able to do something quite simple of just doing kind of a buffered reader and then just looping over that file, reading a certain number of bytes at a time. Once it exceeds my maximum, that's it, I can bounce the connection. Kind of one of the things I suppose is, you might ask, is why not just use the content length? You can use content length, but not all servers will actually validate that the content length of the body equals what's defined in the kind of the HTTP header. It should. That's kind of the protocol, but I find that it's always best to validate the amount of bytes that you're trying to write to a disk, as opposed to trusting something like the content header and validating that what the content header said is actually what you've got. So we've got that so far. So the next step that we want to kind of look at is how to get files back. And I think with Go, this is actually really, really, really easy, because we've got some wonderful sort of methods inside of net HTTP. So let's define our get file server. Okay, so we're going to create, again, a new handler. So I'm going to call this the get handler. It's going to be sm.methods http.methodGet. I'm going to create a subrouter. So I'm just using the standard Gorilla get handler dot handle func. Now, what's my path going to be? Well, actually, my path is going to be exactly the same. I want to be able to have my kind of controller set up so that you specify images as the kind of the root path, and then you specify the ID of the product for which the image relates, and then the name of the image. So I can do that, and then I'm going to pass my handler. Now, the nice thing about using kind of the default methods is for serving files, I don't need to specify any specific handler. I don't need to create my own, because there's already one that exists for me. And that is HTTP Fileserver. So let's just have a look at what that is in the documentation. So Fileserver, where we find it, there we go. So what Fileserver does is, Fileserver is an implementation of an HTTP file server. So it returns you a handler which allows you to write files to the response. Fileserver automatically will read the file from your disk at the location that's given. It will automatically determine the content type and set the content type header for your file, and it'll just automatically wrap it up in a response stream for you. And it's really, really easy to use. So I use Fileserver, and Fileserver expects a directory. So the directory that Fileserver is expecting, you're going to use HTTP directory. And what HTTP dir does is it's going to kind of give you the location of a directory to a file system. It kind of converts all of those URI paths into file system paths. It's a nice and simple piece of code. We can see here actually the implementation, and I really recommend you kind of look at the implementation where possible at some of the Go code. It's got some great ideas of getting some nice patterns and practices for your own stuff. But let's see how we can implement that. So we're going to do HTTP file server, and what we will do is HTTP dir, and we'll do the location of our directory. So we're going to use our base path, and we can do that like so. Now, when I kind of save all of this up and I go and run it, then what I can actually start to do now is serve those files back. So remember, we've got all of these files. We've got test, we've got SDF, we've got whatevers. Let's run our server and see how easy it is to do the file server. Run that there. There we go, running. Okay. So we kind of show how we can post files there, but we can also retrieve files. So I can quite simply just do that curl again, but this time I'm not going to specify my data. And I'm getting, whoa, hang on a minute. What do you mean? File not found. Why am I getting file not found? Well, that doesn't make sense, does it? there's a little bit of a gotcha here. You see, what is going to happen when you're sort of issuing this request is that Fileserver is going to request the location of the file from HTTP dir, and the value that it's going to pass to the file is going to be the path here. So it's going to be images/1/test.png. Now, if you look at the root, well, we've specified the root to be base path. So in effect, what is happening is I'm trying to do a lookup of a file path, images/1/test.png, from the kind of the base path of file store. Well, there is no images folder in file store, so that's going to fail. But that's kind of just the way that it works. If I'd rooted that at a kind of a much simpler, just like a dots path, and everything worked, it would be fine. Thankfully, there's a way around this. We can again use something called HTTP strip prefix. So let's take a look in the docs. What does strip prefix do? Well, I want to print that. I want to find it. So what strip prefix does is it returns a HTTP handler that serves HTTP requests by removing the given prefix from a request URL's path. So let's have a look at an example here. Oh, there's a surprise. Look at that. The example is actually what we want to do. It's HTTP strip prefix around an HTTP file server. I wouldn't be surprised to find that sort of strip prefix was very, very specifically built for this purpose. But it works beautifully. So what is the prefix we want to strip? Well, it's images, because that doesn't exist in our path. And then we're just going to pass it the handler. So that's HTTP there. So let's run our file server again. So we're going to run our file server, and we've got product images. We're starting our server, and we're going to bind address 1990. Let's do that curl again. Now this time the curl is working because we've done that strip prefix on the file server. So that's actually really, really nice. And what you're seeing there is obviously a load of garbage. It's just the kind of the binary representation of that file. What is the file type? File type's image PNG. So it's actually detecting it correctly. So the nice thing about the HTTP file server is HTTP file server has read the file from disk, and it's automatically kind of determined that it's a PNG, and therefore it's kind of written that out to our folders and our disks. And I'm out of time, but we've kind of started to make some headrows into this. I think we've kind of seen some interesting things. We've seen that, you know, it's pretty straightforward to be able to upload files, because response.body is just something that you can read from as a stream. It's just an IO reader closer. And we've seen that the HTTP file server and the HTTP directory give us a lot of flexibility around just that kind of simple ability of, well, just like, you know, serving very, very straightforward and very, very simple files. But what I want to look at on Sunday in the next episode is just polishing this service up. So let's look at how we can implement gzip compression. So let's zip those files before we send them to the user. Let's speed up all of that process. And let's look at how we can implement multi-part requests, because a multi-part request is very different from the way that I've been uploading files. I've literally just been uploading the file as part of the response body. The browser doesn't necessarily work in that way. The browser is going to want to send an HTTP multi-part form post, and we'll see how that goes. Got built-in handling for those. As always, I thank you so much for watching. I'll edit up this video and I will post it up in the links. I hope to see you again. If you enjoy, like and subscribe. Smash the bell button for updated content. And please, in the comments below, any content that you want to see. As always, and have a great evening.